Okay, so this is the continuation of the notes from yesterday. So, Chapter 5, trig functions, the unit circle approach. So we talked about the unit circle. The equation for the unit circle is x squared plus y squared equals 1. We used that equation for the unit circle to show that a point was on the unit circle by substituting the x and y values and showing that we end with a true statement. Then we also use the unit circle equation to find a y value given an x value, knowing that the point is on the circle and that the point is in quadrant 4. So we talked about quadrant 4 points have positive y values and positive x values and negative y values. So we knew the y value we were looking for would be negative. We substituted the x value in and solved for y, and we found that y was going to be negative 1/2. Okay, we also talked about the positive direction is counterclockwise, the negative direction is clockwise. This is the starting point on our unit circle. Okay, in our unit circle it has a radius of 1 and is centered at 0, 0. The terminal point is the point you end at after moving along the circle t units. So these are the terminal points. For given values of t. So we looked at moving on the circle in the positive direction, also in the negative direction, and these were the ordered pair of the point that we would end at after moving t units. Okay, and then the other thing we did was we started filling in our unit circle. So we talked about pi over 4, and we found that pi over 4 had a terminal point of root 2 over 2, comma root 2 over 2. Oops. And it turns out that there is a whole family of points that have very similar terminal points. So the point, oh dear. The terminal point 3 pi over 4, which is right here, is going to have the same y value as pi over 4, and it's going to have an x value that is negative. So the terminal point is going to be negative root 2 over 2, comma root 2 over 2. Okay, 5 pi over 4 is going to also have similar points, along with 7 pi over 4. Okay, so 5 pi over 4 is negative root 2 over 2, comma negative root 2 over 2. And then 7 pi over 4 is going to have positive root 2 over 2, comma negative root 2 over 2. Okay, so we can fill in those 4 values on our unit circle. A similar thing happens when we look at the pi over 6 family. So this is pi over 6. Okay, this is a sixth of the way along the circle. Okay, so this would be 180 degrees. If we divide that by 6, we find out that this is a 30-degree angle. So if you imagine a line here, then you would have a 30, 60, 90 triangle, assuming that this makes a right angle. This is again a special triangle. So let's just draw over here our triangle. So we have a 30, 60, 90 triangle. And we know that this is 1 unit because it's a unit circle. And we know that because this is a special right triangle, this side is 1/2 of this side. So this distance is 1/2. And if you use the Pythagorean theorem, you'll find that this side is root 3 over 2, making this point, this terminal point, root 3 over 2, that's the x value, comma 1/2. Okay, and the pi over 6 family contains 5 pi over 6, which is right here, 7 pi over 6, which is right here, and 11 pi over 6, which is right here. These are all going to have almost the same point, just changes to the signs. So 5 pi over 6 has a negative x value and a positive y value. 7 pi over 6 has both negative, and 11 pi over 6 has a positive x value and a negative y value. Okay, and the last set of points we're going to look at is the pi over 3 family. So the pi over 3 family contains pi over 3, 2 pi over 3, and this one is 4 pi over 3, and 5 pi over 3. Okay, and it's a similar process when we drop a perpendicular line down. We end up with a special right triangle here once again. Okay, and because this is a third of the way across 180, this ends up being a 60-degree angle. So we end up with a 30, 60, 90 triangle. So it's going to be pretty much the same as the other one. The last family we looked at, this is still 1 unit, so we know that this is 1/2, and this is root 3 over 2. The difference here is that our x value is 1/2, and our y value is root 3 over 2. And I'll let you fill in these other 3 points, which are going to be the same as this point, except with different signs. So fill those in on your unit circle. And then I want to look at finding terminal points. So negative pi over 4. Okay, so we always start from 1, 0. Negative means we're moving in the clockwise direction. And if we're moving pi over 4, that means we're halfway to pi over 3 pi over 2. So this right here is negative pi over 4. And the terminal point, which you know by filling in your unit circle, is going to be root 2 over 2, comma negative root 2 over 2. So you want to reference your unit circle to find these values. Okay, so now we're going to look at t equals 3 pi over 4. So 3 of pi over 4 is 3/4 of the way to pi, right here, and we move in the counterclockwise direction because it's positive. This point right here is negative root 2 over 2, comma root 2 over 2. Okay, and then lastly I want to look at negative 5 pi over 6. So again, we always start from 1, 0. Negative means we're moving in the clockwise direction. 5 pi over 6 is going to get us right here. So 5 pi over 6 in the negative direction is actually the same as 7 pi over 6. Right, negative 5 pi over 6 in this direction is the same as moving 7 pi over 6 in this direction, and that's going to bring us to the point negative root 3 over 2, comma negative 1/2. Okay, so these are the terminal points for these given t values. And I'll let you try these. Actually, did I give you the definition? Sorry, you need the definition for reference number first. So the reference number, if t is a real number, the reference number, t with a bar over it, is just the shortest distance along the circle between the terminal point determined by t and the x-axis. It's the shortest way to get to the x-axis moving along the circle. Okay, so if we go back and look at these three examples here, so 5 pi over 6. 5 pi over 6 means we move along the circle to here. There's 5 pi over 6. The reference number means the shortest distance along the circle until you get to the x-axis. So this distance right here is going to be pi over 6. So t bar is 5 pi over 6. Nady, hold on. Sorry. Okay, so the distance along here is pi minus 5 pi over 6, or just pi over 6. Okay, if we look at 7 pi over 4, 1, 2, 3, 4, 5, 6, 7 pi over 4 is right here. The shortest distance along the circle is right here, and that distance is pi over 4. So t bar in this case is pi over 4. And in essence, the reference number really tells you what family it's in, so it's going to help you find your terminal point. Okay, and lastly, I want to look at negative 2 pi over 3. So negative 2 pi over 3. So let's see, 1, 2/3 of the way. So there's negative 2 pi over 3. Okay, and the shortest distance along the circle is right here, which is pi over 3. So for part C, t bar is pi over 3. And that's the 3 we just did. That's the 3 we just did. And that's it for now.